All right, so for this one, this is absolute value with inequalities, okay? So we're going to treat it like the absolute value, okay? So this splits into two. This is a possible answer. M plus 2 is less than 11. See how I didn't change anything? And then over here, M plus 2 is greater than negative 11, okay? So that changes and that changes on this side. And then you solve both equations. So there's going to be M is less than 9 because I subtracted 2 on both sides. This one's going to end up to be M is greater than negative 13 because I subtracted 2 from both sides. Now, when this is a less than question, it's going to be written as if it's an and. Okay, so less than is going to be an and. Okay, so now it has to be less than 9 and greater than negative 13. So I'm going to graph it over here so you see it. Let me do that in purple. Okay, so here we go. This is going to be negative 13, and 9 is going to be somewhere over here, you know. So negative 13, here's a circle. And it's open because it doesn't have the equal to sign in it. And M is greater than 13, so it's definitely going this way, okay? And then this one here, we'll do it in a different color, we'll do it in green. It's gonna be 9, open circle, and it's less than 9, so it's definitely going that way. Now, where do the green and the purple cross if this keeps on going this way and the purple keeps on going that way? Okay, so seeing as though this is the only spot where there is green and purple, because the green's supposed to keep on going and the purple's supposed to keep on going, but this is the only place where they're both, this and that is happening. So this is the only solution set. So thicker line to reproduce. So this is the solution set, just this. Okay, if this is a filled in circle, I'd count that. If this is a filled in circle, I'd count that. But because it's not, it's just anything more than 13 and anything less than 9 falls in the circle that I made in black. So that's the and. So for this one, okay, same rules apply. We're going to split this. It's going to be 3n plus 6 is greater than or equal to 12. Nothing changes. And the other solution set is going to be 3n plus 6 is less than or equal to negative 12. Okay. Let's go with purple to solve it. Let's keep on going with blue, or yeah, let's go with blue just to finish this up. So this equation is going to read, actually we'll go back. Okay, we're going to do this equation, subtract 6 from both sides. 3n is greater than or equal to 12. Divide by 3 on both sides. N is greater than or equal to 4. Here I'm going to subtract 6 from both sides. 6 is gone. This is now 3n is less than or equal to negative 18. And then I divide by 3, and n is less than or equal to negative 6. So when you have a greater than sign, it's going to be treated like an or. Okay, so back to the purple graph. Okay, so this one's going to be negative 6 is over here, and it's filled in. And the 4 is also filled in. And this one is going, n is less than negative 6, so less than will be this way, because it's less than negative 6. And the other one comes out to be, n is greater than 4. Now in this one, they don't have to cross. It's this one or that one. I don't care which one, okay? Both of these are right. So if I was to make black all the correct answers, okay, it would be all of this, including this, all of this, including this forever. So any answer less than -6 or any answer more than 4 will be a correct solution to this problem. So the greater than sign is treated like an or, and the less than sign is treated like an and. My class made up a statement, let me see here, less than, okay, to remember that less and, okay, and then they said this one is going to be greater, okay, so or goes with the greater than sign. All right, so that's a nice way to remember it. Next, here we go. So here, I've done all the math for you, and you just have to tell me what I've done in each step, okay, using the vocabulary from the chapter we were working on. So, for this one, okay, this is given. This is what they started with, okay? So you have to tell me how I got here. So how did I get from here to here? What changed? The 4 minus 3 turned into a 1. So this was substitution. Okay, I substituted a 4 minus 3 for a 1. Okay, now then I did 7 times 1 and then 7. So 7, so it's just 7 times 1. Okay, so this is a multiplicative identity, is what I'm writing here. So multiplicative identity. Okay, because it didn't change its identity. 7 times 1 doesn't, anything times 1 doesn't change its identity. It stays the same. So the multiplicative identity. Now, from here to here, the 5 times 1 over 5 turn into 1. Now, you should know that any number times its inverse makes 1. So this is called the multiplicative inverse. Okay? So that's how we got from here to here. I did the multiplicative inverse. This multiplies to make 1. Then here, I did 7 minus 1, and I turned it into a 6. That's substitution. And then 6 plus 1, I turned it into a 7. That's also substitution. And that's it. That's how you do this one. Okay? You're going to explain the steps using the vocabulary from this section. Okay? I might have a key up, because usually these questions have a key, so I might make a key for that. But you have to know what the words mean, or it'll be confusing. So this one, they want you to evaluate 5 times 7 times 4 times 2 using the properties of numbers. So I've done it for you, how somebody would do it in their head quickly. This is what they're doing. Now the order for multiplication, if all of it's multiplication, the order I get to move it around however I want, okay? So, and it won't change the result. So here I moved it around. If I move things around, it's called the commutative property. If I can move things around and it makes the same answer, that's the commutative property. Then here I grouped them up without changing the answer. If I can group them up without changing the answer, that's the associative property. Okay? Then they multiplied, so I substituted this for that, and I substituted this for that. So that's substitution. Okay? And then here again, substitution. Substitution. And that's it for that now. So you just have to know the difference between associative property and commutative property. Commutative property, like your commute to school, is when you move things from one place to another. Associative is who you associate yourself with. So if you put parentheses around things or change the things that are in parentheses, that's the associative property. You're changing who you're associating yourself with. Okay? Let's see if this goes any more to the right. No, so we're going up. Okay, so this one, I'm giving you coordinates, okay, or relations, and you're going to be setting it up for me in these 3 situations. So I want it in a table. Okay, well, if you want this in a table, here we go. 2, 5, -2, 3, 5, -2, -1, -2. That was pretty easy. Graphing 2, 5. So 2 to the right, 5 up. Negative 2, 3. Negative 2, 3, right over here. 5, 2, so 5 and then negative 2. That'll put you over here. Negative 1 and negative 2. Okay? If one of these dots is wrong, you're going to be wrong. So make sure that you know how to graph and find coordinates. These are always x, these are always y. Or domain and range. Okay? So domain and range for this one. Domain are all possible x's. So all the possible x's are 2, negative 2, 5, and negative 1. What are all the possible ranges? 5, 3, negative 2 I already used, well, negative 2 I haven't used yet, but then negative 2 I already used, so I don't have to write it again. You don't write it twice here. You don't say, you can be a 3, you can also be a 3, you can also be a 4, you can also be a 4. You don't repeat what the options are when it comes to possible y's. And that's it. There's no connection for these. These are all the possible answers. This is everything. So then you're just mapping it, you're graphing it, and making it in a table. Pretty simple. And then here, okay, we did this last year. You're describing what's happening in the graph, but using more technical terms. This time you're not giving me a story, you're telling me what's happening. So here, they're traveling, okay? They're covering distance for a certain amount of time in this little increase here. So every time there's a change in the slope, you have to tell me what's going on. So here, they're traveling, so they're traveling, covering a distance, okay? Because it doesn't tell you anything down here. So they're traveling, covering a certain amount of distance. Here, what's happening? They're not moving, okay? So no movement. They're not making any distance. They're not traveling any distance for this period of time. And then here, they begin traveling again. Okay? So this doesn't say distance from home or anything like that. So this is just distance travel. So if this said distance from home, this would be traveling away from home, not traveling at all, traveling away from home, and if it went down, it'd be traveling back towards home. Sometimes it goes like this, and then it goes like this, which means I'm traveling faster. Okay? And I think that's the last one. Yep, that's it.